Algorithm MaxMin. So what do you mean by MaxMin? So MaxMin is a algorithm which is solved using divide and conquer approach. So in the previous session we have discussed about what do you mean by divide and conquer general algorithm and what are all the examples. So one of the example is MaxMin. So let us start writing algorithm MaxMin using divide and conquer approach. So what do you mean by algorithm MaxMin? So very simple. Algorithm MaxMin, we have four parameters I, j, max and min, right? So we take what? Simple. Initially we check whether the problem is small or not. How to check the problem is small? If I is equal to j. If the problem is small means what? We have only one element. When it is having one element, the maximum and minimum both are a of I only. So we have only one element, that is the maximum and that is the minimum. Assume that we have two elements. If we have two elements, what it means? The condition is if I is equal to j minus 1. If this condition is true means what? We have two elements. When you have two elements, what we do? We compare both the values. That is, if a of I greater than a of j. If this condition is true means what? The max is equals to a of I. Min is equals to a of j. If the condition is false means what? Else max is equals to a of j and min is equals to a of I. That means what? We are checking whether the problem is small or not. So the problem is small when you have one element, the problem is small, and when you have two elements, the problem is small. If you have more than two elements, so what you do? We are writing an else here. We are writing an else here. This else I am writing here. Else. That means what? More than two elements. If you have more than two elements, what we do? You divide the problem into two pieces. Mid is equals to low plus high by 2. So what is the low here? I plus j by 2. That means what? The problem is divided into two pieces. Now the first piece you are applying MaxMin. So same MaxMin you will apply. MaxMin of the first piece. I comma, mid comma, max comma, min. And on the second piece also once again you apply MaxMin. MaxMin of mid plus 1 comma, j comma. Only difference is you take the temporary variables max 1 and min 1. So you are checking whether the problem is small or not. If you have one element, that is a max, that is a min. If you have two elements, compare them and find out max min. If you have more than two elements, divide the problem into two pieces. The first piece you are solving the same technique and the second piece also you are solving the same technique. So in the first piece you will get one max and min, and the second piece you will get one max and min. Now we compare both those max and mins. So how will you compare? Very simple. The first max and min. If the first max, if it is less than max 1. So this max and this max I am comparing. If the max is less than max 1, that means what? Max 1 is the maximum. So that is max is equal to max 1. Similarly, the min and min 1 is compared. If min is greater than min 1, if this condition is true means what? Min is equals to min 1. That means what? This set max and this set max is compared, and this set min and this set min 1 is compared, and you are finding out the one maximum from these two and one minimum from these two. That is final answers. Are we clear? So this is about MaxMin using divide and conquer approach. So what is happening if you observe? Very simple. The problem example, you have 10 elements. That is 1, 10, some maximum, some minimum. You divide into two pieces. This is having 5 elements. This is having 5 elements. 1, 5, max, min. 6, 10, max, min. Once again, this is divided into 2 pieces. This is divided into 2 pieces, and so on until you find out the max. Slowly they will club together and finally we get an answer. And if you observe here, this will have one max and this will have one max. So this answer max and this answer max 1 is compared and final max is calculated. And this min and this min is compared and final min is calculated. So this problem MaxMin can be solved in 2 ways. One is straightforward technique, which we usually do using a simple for loop, whereas the MaxMin using divide and conquer approach, checking whether the problem is small, 1 element, 2 elements, more than 2 elements, divide into 2 pieces, apply the same logic, divide and conquer approach, and compare both and find out the final max and final min. Okay, so what is the time complexity of MaxMin? So the time complexity of MaxMin is n, O of n. Are we clear? So thank you. See you in the next session.